Hi, this is Rohan from educator.ai. Let's dive in. In this video, we build up Retrieval-Augmented Generation or RAG, one small idea at a time. By the end, you'll understand the full pipeline well enough to review a pull request that uses it. A large language model only knows what it saw during training. It has never read your internal wiki, your product docs, or yesterday's support ticket. Ask it about those, and it fills the gap with a plausible-sounding guess. That guess is called a hallucination, and it's the core problem RAG exists to fix. Here's the naive flow. A question goes straight into the model, and the model answers purely from memory. If the answer lives in your data, and not in its training, you get something fluent and wrong. We want to close that gap without retraining anything. Think of it like an exam. Closed book, the student answers from memory and sometimes bluffs. Open book, they first find the relevant page and keep it open while they write. RAG turns your model into an open book test taker. Retrieve the right passage, then answer using it. The whole trick is surprisingly simple. Before calling the model, we fetch text that's relevant to the question and paste it right into the prompt. The model then answers using that supplied context. Nothing about the model changes, we just improve what it sees. How do we find relevant text? We convert each passage into a vector, a list of numbers called an embedding, where similar meanings sit close together. We embed the question too. Notice the money back question lands right beside the refund and returns passages, far from shipping. Closeness means relevance. This happens ahead of time, offline. We split documents into chunks, bite-sized passages, embed each one, and store the vectors in a searchable index, often called a vector database. Chunk size matters. Too big and you drown the prompt in noise, too small and you cut answers in half. At query time, we embed the incoming question and search the index for the nearest vectors. We keep the top K, say the 3 or 5 closest chunks. Top K is your budget knob. More chunks means more grounding, but also more tokens, more latency, and more cost. Now the augment step, the A in RAG. We stitch the retrieved chunks and the question into a single prompt, usually with an instruction like answer, using only the context below. This is where grounding actually happens. The model is now looking at your data, not just its memory. Here's the full picture. Embed, search, and build. The prompt happen together on every request. That's the retrieval and augment block. Then the model generates. Because the answer came from specific chunks, we can attach citations pointing back to the source. That's how RAG reduces hallucination and lets users verify the answer. One thing developers often miss: retrieval does not answer the question. It only supplies context. The model still generates every word. So if retrieval hands over the wrong chunks, or none at all, the model may fall back to memory and hallucinate anyway. Retrieval quality is the foundation everything else stands on. Let's make it concrete. We embed 3 chunks and a question with a toy embedding, then score each chunk by dot product with the question vector. That's cosine similarity for unit vectors. The highest score wins. Real systems use trained embeddings and a fast index, but the shape is exactly this. Embed, compare, pick the nearest chunk. Here's the real call. We join the top 3 chunks into a context block, and the instruction tells the model to answer only from that context and to admit when it doesn't know. That curbs hallucination. Temperature is 0, because we want faithful, repeatable answers, not creativity, and we never trust the raw output. Validate before using it. 2 traps to avoid. First, RAG is not fine-tuning. It never changes the model's weights. It changes what you put in the prompt at runtime. Second, when an answer is wrong or ungrounded, the reflex should be to inspect the retrieved chunks, not to blame the model. Most RAG bugs are retrieval bugs. Use this as your checklist on a pull request. On the left, the prompt insists on grounding. Top K and chunk size are bounded to control cost. Citations are returned, and there's an evil measuring grounded accuracy. On the right, red flags. Dumping entire documents, no I don't know fallback. Retrieve text, treated as trusted instructions. That's prompt injection, and personal data sent to the model with no redaction. So to remember, RAG retrieves relevant chunks, augments the prompt, and lets the model generate grounding answers in your data and enabling citations. The model still writes every word. Retrieval only feeds it context. And when things go wrong, Look at the retrieved chunks first. That's retrieval-augmented generation.